Hi guys, welcome to Geeks for Geeks. In this tutorial, we learn how to calculate the number of spanning trees for any graph using the matrix tree algorithm, also known as the Kirchhoff's theorem in graph theory. It is a very useful algorithm but is less widely known. So first, we need to recall some basic facts. A tree is a graph with no cycles and is connected. A spanning tree is a tree which has all the vertices covered, utilizing the minimum possible number of edges. Now consider a graph with cities as its vertices. Let's take Delhi, Mumbai, Bangalore, Chennai, and Kolkata. Currently, this network is a complete graph with 10 edges. We want to be able to have a network where all these cities are connected and we use minimum number of edges. This is actually when we get a spanning tree. One such spanning tree will be when we connect Delhi and Chennai, Delhi and Bangalore, Delhi and Mumbai, and Delhi and Kolkata. Now another spanning tree could be if we connect Chennai and Kolkata instead of Delhi and Kolkata in this graph. In this way, we can find various spanning trees of this graph. Now the question is, how many spanning trees are actually there in this graph? If we have a complete graph, according to Cayley's formula for a complete graph with n vertices, we will have n to the power n minus 2 spanning trees. So going back to the earlier examples, in this graph we will actually have 125 spanning trees. Finding these one by one is actually a very tedious task, especially if there are more number of vertices. If a graph is not complete, there are two methods to determine the number of spanning trees. The first method uses the contraction deletion theorem. This is a recursive algorithm which has exponential time complexity. The second method is the matrix tree algorithm, which has polynomial time complexity. In this video, we will study about the matrix tree algorithm. Let's consider an example where we have an incomplete graph. Let's find the number of spanning trees one by one. The first spanning tree will be something like this. The second one will be something like this. This would be the third one. This will be the fourth, the fifth one, the sixth one, the seventh one, and lastly the eighth one. So in total, we'll have 8 spanning trees. Now coming to the matrix tree algorithm for any graph. The first step is to find the adjacency matrix of the given graph. Now we need to replace all the diagonal elements of the adjacency matrix with the degrees of the nodes. For example, element at 1, 1 position will be the degree of node 1 and the element at 2, 2 position will be the degree of node 2 and so on. Next, we need to replace all the non-diagonal ones with -1. Lastly, we need to calculate the cofactor for any element in this resultant matrix to get the number of spanning trees. If you notice, we need to actually subtract the adjacency matrix from the degree matrix and calculate the cofactor of any element to get the number of spanning trees. The subtraction of the degree matrix and the adjacency matrix gives us the so-called Laplacian matrix. To demonstrate this algorithm, consider the same graph we had before. The degree matrix for this graph will be this, the adjacency matrix will be this, and we get the Laplacian matrix by subtracting the two. To get the number of spanning trees, we find the cofactor of any element of the Laplacian matrix. Recall that the cofactor is actually given by this formula. So C11 will be nothing but this determinant. C14 will actually be this determinant. Both these give the same result, and similarly the cofactor of any other element will give us the same result. I hope I was able to explain this powerful algorithm. If you have any doubts or suggestions, please leave them in the comment section below. Thank you.